So let's talk about DNS zones. If you install DNS while you're installing Active Directory, you may not need to worry about zones when you're installing that first AD server domain controller because it should be set up automatically with the zones that are required. But you may need to manually set up those zones if you did not install DNS at the time that you installed Active Directory. You may also need to install DNS on a server that's not a domain controller, so you'll have to manage your zones manually on those servers. You might have to create a stub zone or secondary zones for a primary zone, create primary or secondary zones for an internet domain. In other words, if you have a domain controller, by default, it'll be able to manage its own domain. But if you also have an internet domain and it's a public-facing DNS server, then you'll have to manually create the zones that can facilitate that as well. Although you could also do that out of band from Microsoft Windows Server as well. So there are two different types of zones. When you're creating a zone, you have to decide which type of zone it is. There's a forward lookup zone and reverse lookup zone. So an FLZ or forward lookup zone contains record that translates names to IP addresses, and they allow you to look up things like A records, AAA records, MX records. So just to kind of give you a little background on the vernacular, an MX record is mail exchanger records. So these are when you do an MX record query in DNS, you're asking where do I send email. So that specifically tells you what IP address you want to get or you need to get to in order to do email operations. An A record gives you the IP address for everything else, and an AAA record or quadruple A record is the IPv6 address. So if you're looking for an IPv6 address, then you're going to look at the AAA record. There are other types of records. For example, a text record or TXT record contain other information. This is actually used frequently by Active Directory. So Active Directory takes advantage of the TXT records to provide supplemental information that's needed for Active Directory. A reverse lookup zone, or RLZ, contains PTR records or pointer records that map an IP address to its host name or to its FQDN or fully qualified domain name. And this is how you look up names when you know the IP address, which is a little less common. But that's also a service that's typically needed in most networks. So you can create either a forward lookup zone or a reverse lookup zone. So you have to make that decision beforehand. There are three different types of zones. So beyond the FLZ and RLZ, you have three different types of zones. There is a primary zone, a secondary zone, and stub zones. So the primary zone is the read-write master copy of all resource records for the zone. So that is the authoritative for the zone, meaning that is the source of truth for all the information for DNS for that zone. A secondary zone is a read-only copy of those records. So it's basically a read-only copy in the sense that, not in the sense that it can't change, because it does change from the primary. The primary zone can push changes to a secondary zone, but it doesn't change in the sense that you can't use dynamic DNS to update the secondary zone. That has to be done with the primary zone, and that's usually for security reasons. It makes it a little bit more difficult to poison DNS, and it also is good for simplicity. A stub zone is a read-only copy of only the SOA, which is the start of authority, and NS records. In other words, an SOA basically tells you who is the DNS server that's responsible for that particular domain. And for NS records, which allow for doing basic lookups to resolve NSS. It is not an authoritative domain, so secondary and primary is authoritative. In other words, you can rely on that as a source of truth for information about that domain, but a stub zone is not. A stub zone simply tells you where to go to get that information. So it's definitely not a primary or a secondary zone. So these are the three types that you can configure in Windows 2012 Server when you're configuring DNS. In Active Directory, so if you're using Active Directory, you can have Active Directory integrated zones. It's not a new zone type, but is a primary or stub zone with a DNS database stored in an Active Directory partition. In other words, Active Directory has a lot of functionality that relies on DNS, and there's a lot of extra information that DNS has to store for Active Directory, and it's only possible if it's integrated with Active Directory. So when you install DNS to work with Active Directory, it will create the zone in a slightly different way. It's integrated with Active Directory. Of course, you don't have to use DNS with Active Directory. If you don't have Active Directory on your network, you can still use Microsoft Windows as a DNS server. However, if you are using Active Directory, you will have this additional functionality that will be required, and it's a slightly different zone, and it will, for the most part, manage itself for some of the things that I've talked about. The only valid zone type options are primary and stub zones when you're installing DNS for Active Directory. So you can either be a primary or a stub. There are no secondary types. So if you select the secondary zone, the option to store the zone in Active Directory is disabled because it is not supported. So if you have Active Directory, you'll have to choose either a primary or a stub zone. If you do not already have a primary zone, then you'll have to use primary for Active Directory to work properly. If you already have a primary, then you'll be able to use a stub zone. A standard zone is a primary secondary stub zone that is not Active Directory integrated. So if you decide to use DNS without Active Directory, then it would be a standard zone. Standard zones are stored in a text file called zonenames.dns, which is located in your system root in the DNS folder under System 32. It's important to note here that if it is an Active Directory zone, so if you're using Active Directory, the information about DNS is stored in the Active Directory database as opposed to in this standalone database that you see here in this path. So that's the main difference here. If you're using an Active Directory integrated zone, then all of the information is stored within Active Directory, and it's integrated with Active Directory. With a standard zone, it is not stored in Active Directory. Instead, it uses the standalone flat file database that you see here. It's mostly installed on standalone servers that need to provide name resolution services for network resources outside of the domain, or in networks that don't use Active Directory. For example, if you have a mostly Linux or Unix-based network or Mac-based network, you're probably not going to use Active Directory in those environments. But in the corporate world, this is not common. For the most part, I think probably 95% of companies that are over 500 employees are probably using Active Directory for authentication, so we'll probably need DNS in those networks anyway. Zone replication is the transfer of zone changes from one DNS server to another, and this is one of the really important things that DNS can do. It can take information, and this is what makes it a database that doesn't have a single authority. It's a distributed database, right? Just like Active Directory is a distributed database, DNS is also a distributed database, and there's a mechanism called zone transfer that allows the information to be distributed among all these different servers. So Active Directory integrated zones have advantage over a standard zone because it has automatic zone replication. It's configured for you because it's part of Active Directory. We already have a mechanism in Active Directory that is a distributed database. It's already managed by Active Directory, so we don't have to rely on DNS, but the DNS protocol to do that for us. We can simply use what's available in Active Directory. If you're not using Active Directory, then those zone transfers will work within the confines of what's available in the DNS protocol, and maybe not as secure if you're using Windows Server. We also have multi-master replication and update, again, because that's part of Active Directory and how Active Directory works, and it's handling those updates. It's secure because, again, it's Active Directory, so we have that trust that's between servers, so we know we can trust those zone transfers. And it's certainly a little bit more efficient than using DNS because it's part of, again, Active Directory's distributed database, which has some additional tools because it's all one platform. It's all within an organizational boundary. So everything gets a little bit easier in that case. So that's a little bit about zone replication when it's integrated with Active Directory. So after you select the zone type and specify the zone is to be stored in Active Directory, you're asked to select the zone replication scope with one of these options. So you can install to all DNS servers in the forest, to all DNS servers running in a domain controllers in this domain, or to all domain controllers in this domain for Windows 2000 compatibility, and then finally to all domain controllers specified in the scope to this Active Directory partition, or I'm sorry, to the directory partition. So again, this is after selecting the zone type and specifying what type of, the zone, whether or not it's to be stored in Active Directory. You have to select, if you are installing an Active Directory, you have to select the zone replication scope. So in other words, is the replication within the entire forest, only within our domain with Windows 2000 compatibility, or to all domain controllers specified in the scope of the directory partition? And you'll see that option here. This is what it looks like. So you're basically saying, how far and wide can this particular DNS server work with zone transfers and be able to replicate information between different servers. And again, this is if you are installing with Active Directory. If you're not installing with Active Directory, this of course will be a little bit different. So the next step, after you get all this set up, you're going to have to give your zone a name. For an FLZ, the name, so for a forward lookup zone, the name of the zone should be the FQDN, or the fully qualified domain name. For example, google.com is a fully qualified domain name. Something.microsoft.com would be a fully qualified domain name. So it's the scope, it's the domain name for the scope that you are managing. So if your DNS server is managing everything for the entire company.com, then that would be the FQDN. But if this is just managing division.a.company.com, then that would become the FQDN, or that would be the name of the zone. For a reverse lookup zone, you're going to have to use the IPv4, IPv6 name for the zone. And so typically you'll use the network ID portion of the zone, and then it will be suffixed with in.address.arpa, basically. So it'll look a little bit different. It'll look somewhat like an FQDN, but it'll have numbers on the front, essentially. And those numbers, by the way, would be the IP address for the network. So the final step allows you to choose whether and how to use dynamic updates, which can be configured in one of three ways. So there are three ways to do dynamic updates, and before I go further, I'll just explain briefly what a dynamic update is. A dynamic update is every time, let's say you have a DHCP server, and every time somebody gets a DHCP address, that has to be updated in DNS. Your DHCP server can do that. It can notify the DNS server that there's a new computer on the network. This is the computer's name. This is the computer's IP address. And then that information can be cached on the DNS server, so if anybody needs to get resources on that device, they know exactly which IP address it is. That is a dynamic update. There are other ways to do dynamic updates, and there are other places and reasons to do dynamic updates, but that's the most basic. It's a new device on the network. It registers itself with DNS. So there are three ways that you can allow these dynamic updates. You can allow only secure dynamic updates. You can allow both non-secure and secure dynamic updates. And finally, do not allow dynamic updates at all, in which case you would have to keep your DNS server updated manually. So these are your three options. The problem with DNS is that it's a very trusting protocol. So if you allow non-secure updates in an unsecure environment or an environment that's not trusted, then it is possible for someone to poison DNS, and that's kind of a challenge. So a lot of the root DNS servers on the internet have found ways to work around and solve these challenges for the most part, although every once in a while we still hear about poisoning of DNS and the breakdown of that trust. Within our own networks, it's usually okay to do both non-secure and secure dynamic updates, depending on the size and the type of the network. So there are certainly some scenarios where it may not be appropriate, but these are your options. It's either secure, non-secure, or secure, and then do not allow any dynamic updates at all, in which case you'll have to manage that on your own manually. So dynamic updates enable DNS client computers to register and dynamically update their resource records within the DNS server whenever a change occurs, which I explained at the beginning of this slide. There are some PowerShell commands for DNS management. So if you want to set up zones and manage zones from the PowerShell, you can certainly do that. And of course, you would have to do this if you had server core and you did not have a GUI or a way to connect to it from another machine. So this would be the command to install DNS. This would be the command to create an Active Directory integrated forward lookup zone. And you can see here the name is the FQDN. This is the command to create a standard forward lookup zone. So this would be one that is not integrated with Active Directory. A couple more commands for you. So this one creates an Active Directory integrated reverse lookup zone with forest-wide replication, meaning it replicates for the entire forest. And then here we have a command that creates a reverse lookup zone and stores it in a file named 10.10.in-address.arpa.dns. So this would be a non-Active Directory integrated zone. All right, so resource records can be created dynamically or as static records. Dynamic records are created by a resource or with a DHCP server. In other words, dynamic records are updated dynamically on the network. So when someone adds a new computer, it automatically tries to register itself with DNS. That is a dynamic record. A resource record is when or a static record can be one that we create manually. So for whatever reason, we want to create a record to tie an IP address to a host name, we can do that manually. That is a static record. So again, we have dynamic resource records and static resource records. One happens automatically, the other one we create manually, and you'll certainly see those when you look at a DNS server. It'll show you the dynamic records versus the static ones, and you can add static records on your own. So dynamic DNS records are created and updated by all the resources or by DHCP server when IP address is leased or renewed. So most DHCP servers will do that for you. Of course, the Windows one will as well, and we're going to learn about that in the next unit. Each time a dynamic record is created or updated, a time to live or TTL value and a timestamp are added to the record. In other words, how long is this record good? How long should it remain in the DNS server before it drops off because it's not considered reliable or no longer reliable? If the record expires, then it should be deleted from the database. A static DNS record does not typically expire because it's created manually by the administrator. So to create a static record, you're going to right-click on the zone in which you want to create that record. In a forward lookup zone, which is the most common type, you're going to create a new host record. You're going to enter the name and create the FQDN, or it will create the FQDN automatically. And you'll put the IP address or the A record to which it matches, or the quadruple A record. If you select Create an Associated Pointer PTR Record checkbox, a pointer record will be created in the reverse lookup zone if you're using a reverse lookup zone. So it'll automatically create that for you. And of course, you can do this as well with the PowerShell. So here's how you add an A record for a host named host1 in the csmtech.local.zone FQDN. So that would create that for you. And if this is how you would do the AAA record, which is, of course, our IPv6 record for DNS. All right, so to create DNS records, you can also add a CNAME, which is an alias record. So we haven't talked about CNAMEs yet, but it's another type of record. And this is the command you would use to create a PTR record, which again is for reverse lookup zones. So as far as configuring DNS zones, zones can be viewed and changed in the DNS Manager. And the DNS Manager provides a few options. We have status, type, replication, dynamic updates, and aging. So you'll see these options in the DNS Manager when you're looking at your zones. All right, so the start of authority records, basically every zone has to have an SOA or a start of authority record, and it contains information that identifies the server that is responsible for the zone, as well as some of the operations for that zone. So an SOA record is going to tell you the serial number and the primary server, as well as the responsible person, the refresh interval, retry interval, and when it expires, and of course a time to live for that record. Basically, an SOA tells you who is the source of truth for DNS within the network, who is the authority for DNS for that particular FQDN. So that's basically what an SOA is. Name server records, or NS records, specify FQDNs and IP addresses of authoritative servers for a zone. So NS records are used to refer DNS queries to a name server that has been delegated authority for a subdomain. In other words, this is how you look up information about who a source of truth or authority is for a given FQDN. And glue A records are A records containing a name server's IP address and are used to resolve NS record information. So on Windows DNS servers, glue records are created automatically in a DNS lookup on the NS records FQDN. So when you create that FQDN, it'll automatically create that glue A record. A stub zone, as we talked about before, it's a special type of zone, and it only contains an SOA record and the NS records. So basically, all a stub zone does is tell you where to go. It refers you to the right place to get information about that domain. So it's the reason for using a stub zone is maintenance of zone delegation information in lieu of conditional forwarders, faster recursive queries, distribution of zone information, and so forth. So a zone transfer is basically when we copy part of or all of our information from one DNS server to another. And it's usually the result of a second server requesting the transfer from another server. So they can be initiated in two ways. They can be at a refresh interval that happens periodically or through a notification. In other words, requesting that transfer. So zone transfers are configured in the Zone Transfer tab of a zone's property dialog box, which has the option for allowing zone transfers to any server or to only servers within the name servers tab, or only to the following servers. You can put manually which servers are allowed to do zone transfers. You can use the notify option, which will allow zone transfers through the notify option in DNS. And again, this is mostly to move information around the network, so it's mostly to replicate information between different DNS servers. As I said before, this will actually usually will be handled by Active Directory. If you're in an Active Directory with DNS, a lot of this will be handled through distributed database through Active Directory. So there are two types of zone transfers. There's a full zone transfer and incremental zone transfers. So both master and slave DNS servers must support incremental zone transfers to use them. And during the initiation of an incremental zone transfer, the serial number decides whether the slave or master determines the differences between its current zone data and the zone data for the other server. WINS was a legacy service that was available for Windows back in the old days before we had FQDNs and before we integrated DNS with the internet and the wider internet from our Windows networks. We had sort of an internal domain name system called NetBIOS. NetBIOS simply mapped a simple name. It did not have dots in it, so it wouldn't be something.com. It was just a simple 15-character name that identified all of the resources on a network, and that was called the NetBIOS name. NetBIOS can work in a decentralized environment whereby all of the computers can manage their own NetBIOS database of servers that are or resources that are within reach of that particular system on a local area network. So NetBIOS sort of happens automatically in Windows if you're not on Active Directory. However, in the old days with Windows, with say Windows NT 4.0 and even some of the newer versions, Wins was basically DNS for NetBIOS. So it's a centralized mechanism for managing the NetBIOS names and for centralizing the lookups for those names, because NetBIOS is not scalable when it's point-to-point or when it's peer-to-peer on a very large network. So Wins allowed the use of NetBIOS on large networks where we didn't need full DNS. It's similar to dynamic DNS in that it keeps a database of name-to-address mappings, and they can be updated by nodes on the network. It's generally used in environments that require NetBIOS resolution. Why would you require that this day and age? It could be because you have specific applications that depend on it. It could be for legacy reasons. It could be because you have old devices or old methods of connecting to things. If this is a requirement to use NetBIOS names on your network, then you're going to need to use the Wins tab to set this up. So you can use the Wins forward lookup tab, do not replicate the record, the IP address, time to live. Again, it's very similar to DNS, but again, this is only for NetBIOS. The Global Name Zone, or GNZ, allows administrators to add a single label names to DNS. So a single label name to DNS is sort of like NetBIOS, where you have a single name rather than an FQDN. So for example, instead of entering fileserver.mycompany.org, you can just put in file server, and that will automatically redirect you to the right server. So as long as you're inside the organization, you can use a single word name to identify something without using its FQDN. This is useful for, and by the way, you have to put these entries manually. You cannot rely on dynamic DNS to do this for you. So this is sort of like supporting what we have with NetBIOS with the single name labels for resources on our network, but we don't have to use NetBIOS anymore. So this is kind of the newer method to do this if you're not going to use Wins. You can use the command shell to do this. The PowerShell, there's a commandlet to add global name zone. So you would turn that on, and then you'll be able to use that. In the next slide deck, I'm going to talk about some advanced DNS server settings that we have available, and I'll wrap it up in that slide deck as well when we talk about monitoring DNS.